Hi everyone, this is Jim. I wanted to talk about building model planes today. This is a Flite Test Mini Mustang. It's part of their Mighty Mini series, and I just finished building it. I thought I would share what I learned from the experience while it was still fresh in my mind. So because this might be a long video, I've divided into 7 sections, and I put the time codes for each section in the description, so you can just go there and go to the section you're interested in if you don't want to watch through the whole video. So section 1 is going to be kind of a rambling introduction, how I got into this sport, and how long it took me to build this, and how much it cost, and just various things like that. Section 2, I'm going to talk about safety issues, how many times I got cut, burned, and stabbed during during the process of building this. And then section 3, I'm going to talk about the power pod. So the power pod is a piece right up here, which is where the motor is attached. So that's a key part of your system, and it's connected via these rods here. The fourth section, I'm going to talk about the receiver. That's which takes the signal from the transmitter and causes the airplane to go and manipulates the controls. The receiver is the servos and the ESC, so how all the electronics is hooked up. The next section, section 5, I'm going to talk about building the body of the plane, including the tailpiece, the rudder, and the elevator. And then after that, in section 6, I'm going to talk about installing all the controls, the motor, the servos, and that kind of thing. And then the last thing I want to talk about is the hatch, and that will conclude the presentation. I wanted to say the hatch comes on and off because you need to get access to the insides there to every time you change a battery. So every time you fly the plane, you're going to be taking the hatch off, putting a battery in, and then putting it back on. And you can take several batteries with you and fly it multiple times. So you'll be taking the hatch on and off. And I actually made a slight modification to the design. So that's the only thing I changed in terms of building this. Otherwise, I just followed the Flite Test instructions. And I have to say, Flite Test has a great website, and I'm very happy with the company overall. So any changes I made are my own responsibility, but it doesn't reflect any criticism of them. I'm very happy with them overall. Flite Test has a YouTube channel with all of their build videos on it, and that's how I built this plane. I bought the kit from Flite Test and I followed along with their video. So this is not going to be a build video. This is just going to be pointing out some areas where I had problems and maybe a few suggestions to help you avoid problems as well. So how I got into this sport was, it actually goes back a long way. So when I was younger and I had a young son, I bought him a radio-controlled balsa wood glider for Christmas one year. And we spent about 6 months building it. Took a while. And we flew it that summer, and we had some fun with it. And then that was kind of a one-off thing. I didn't do any model building after that, and no more flying. But my son, when he was grown up, he was still interested in that, and when he could afford to, he bought himself a model plane, electric plane, and a transmitter and everything. So he's got all of the gear, and he was taking me along to fly with him. And then one Christmas, he got me, or actually it was a birthday present. He got me a present of this receiver here. It was the Spektrum DXe receiver, and that was included with this was actually a cable and a flight controller, a flight simulator. So I could use this to learn how to fly a model plane using the simulator. And then, he later offered to let me fly his plane. But it was kind of an expensive plane, so I didn't really want to crash it. So what I did was I decided to go ahead and, I'd been watching these Flite Test YouTube videos because he had also introduced me to the Flite Test YouTube channel at the same time. And so I just decided to buy one of their planes and build it, and then learn how to fly using that. Crash that one instead of his. So this was the first plane I built. This was the Mighty Mini Scout, and I flew this a lot, and I crashed it a lot, and eventually it broke down. to the point where I didn't feel like I could repair it anymore. I probably still could have repaired it, but at some point I decided, well, I'd rather get a new model and start over. And so that's when I bought the Mini Mustang model that you just saw, and I just finished building. So that's how I got to it. So I've actually built two of their models in the Mighty Mini series, and you'll notice this one is empty. I don't know if you can see it, but it's all empty inside. I took all the electronics out of this one and put them in to the new model. So to get the new model only cost me $20 or so. I had to pay shipping costs too, but it's a very cheap upgrade to get a new model if you don't mind recycling all of the electronics you had from the old one. So that brings me to the topic of cost. I did want to talk about how much it costs to get into this hobby. So I just wrote down all the things you're going to need here. So you need the transmitter, that's $70. You need a programming cable. This is something that's a lot of transmitters have their programming built into them. They have an LCD or a touchscreen, and you program it that way. But the Spektrum DXe, it's a very cheap transmitter, so it doesn't have that. But what it has is a cable which you can buy as an add-on, that and then a free app, and you can actually just plug it into your phone using this cable and program it from your phone. But you do need to be able to program these transmitters, so it's important to get that. So that's $17. You need a receiver that goes into the plane, receives a signal from the transmitter, and has to be compatible. That was $30, or is $30. I just got these prices off the Flite Test store recently, so these are all up to date. There's the Flite Test Power Pack A. That had the motor, it had the servos, and it had the ESC, the throttle on the motor. That was $58. There's the Flite Test Mighty Mini Scout itself. That's the build kit. That's only $15. And then you need batteries. If you get a couple of batteries, that'll run maybe $30. And I'll put the details about the names of the components that I bought here in the description as well, so I don't have to say them all. I bought a charger for the batteries, and then that's it. That's really everything you need to fly the plane, and you can get up and running with that. And that costs $260 altogether, figuring you spent about $30 on the batteries. You want to get more than one battery, so you can swap a battery out while you're flying. And how many batteries you get, it depends on how long you want to fly. Each battery lasts for maybe 10 minutes. So it's just kind of up to you. I have 3 batteries. So that's kind of the base level. So $260 is ground floor. And but there's a couple of things I would recommend on top of that. One is the simulator. As I mentioned, I started with the transmitter and the simulator. And I think it really helps to have a simulator to learn how to use those controls. Now, the simulator I'm using is called Phoenix RC, but it's no longer available. But there is something called RealFlight 8 Flight Simulator. It seems to be like the latest release of that, or an upgrade or a follow-on to that flight simulator. I mean, it looked very similar in the description, so I think it's the same thing, but it's been rebranded, and it's got a price of $100. So $100 for the flight simulator. And you'll also need some way to connect your transmitter to the PC. And so Spektrum has a wireless dongle that plugs into a USB port that allows you to use the transmitter to talk to the flight simulator program through the USB port. So that's $40 or $45. So if you add those two together, we're up to about $400. And then there's also the materials you need to build the plane. I had to buy a glue gun. Flite Test has a complete kit with everything you need to do the builds, including razor blades, servo centering things, and anyway, that goes, and the glue gun, glue sticks, other things, screwdrivers, and so their kit goes for $100. So if you add all of that up together, it was $260 plus $145 plus $100. It's $505. So $500 is like the full kit. That's everything you need. even if you don't have anything. Now, I didn't buy the Crafty kit myself. It was actually, I would have bought it actually, but it wasn't available on the web store when I was buying this stuff. So I ended up buying a glue gun myself and some razor blades, and we had some X-Acto knives around the house. So I did it that way. And then the first plane I built, it took me about 2 weeks. I was not like working on it continuously. I'd work on it an hour here and an hour there. And then the second plane I built, the Mustang, I built that in less than a week. Now, Josh, who does the videos on Flite Test, he said this would be a fun evening build for you and your friends. So, I think he could do it in an evening. I think it's not that hard. I probably, in that week, I wasn't working every day that week on the plane. Some days I was doing other things, but I had some, longish sessions working on it, 4 hours or 5 hours at a stretch a couple of times. So I maybe put 15 to 20 hours into it all together. I could not do it in an evening, but I might be able to do it in a day if I just sat down and concentrated on it the whole day. But that also included time to redo things that I had done wrong the first time. So that included tearing it apart and putting it back together. So I would say 15 to 20 hours it took me altogether in actual time to build it. Safety. So my number one safety tip is that hot glue flows downhill. You might not have realized this, but hot glue is subject to gravity just like water and other substances. And it is kind of liquid. I mean, it's in a solid form up here at the glue gun, but it gets heated up down here at the tip, and then it comes flowing out. And so if you ever find yourself holding something and then applying glue to it like this is a very bad idea. You see, my hand is downhill from where the glue gun is. So you want to do it the other way around. You want to have your hand up here, and the glue gun. You want to have the glue gun down below your hand. Now it will run down. Sometimes spilling onto your work surface. So I recommend coating the work surface with newspaper. And that's the way I did it. I had newspaper there all the time. In fact, even when you just turn the glue gun on, it takes a few minutes to warm up. And as it's warming up, hot glue will drizzle out of the nozzle. So you should have it set on something that can handle the hot glue spilling onto it. But newspaper works fine. If you do spill some hot glue on you, scrape it off immediately. You should always have some spare or scrap pieces of foam board around. They're left over from the kit, so there's plenty of excess foam board. Just scrape it off immediately. Roll it up with your finger, and then go run some cold water over it, and that should reduce the blistering. At least that's my experience. I'm not a doctor. So those are the two things about the glue. Just watch out for it. And then the second safety tip has to do with, it might be a good idea to make sure your tetanus shots are up to date, because there's a lot of ways you can poke yourself. They use these barbecue skewers in the build, and they have a sharp end. And you poke them, well, through the fuselage here, you can see these little cross pieces here up at the front. These are holding in the power pod. Those are sections of barbecue skewers. You originally push a sharp skewer through, and then you snap these off so that they have blunt ends. But it's just easy to stab yourself when you're pushing that through. So just be careful when you're playing around with these. They're dangerous. And then the other thing that can cause puncture wounds is these control rods. So control rods are used. Well, for example, there's short control rods on the back side here. Can you see it? I move it this way. Yeah, kind of. See a little bit of metal poking out of this. This is called a control horn here. This is the servo here. Gosh, that's hard to do. Everything is reversed. This is the servo here, and then there's a control rod running between them. And as you poke the control rod through the servo, there's like little holes in the servo arm there. You have to poke the control rod through. It's pretty natural just to support the control arm with your finger and poke from the other direction. And that's a recipe for getting a little hole in your finger. So watch out for that. But it's tough to do that. Those holes are actually pretty tight, and so it's tough to poke the control rods through them. So those are my 2 safety tips. I mean, everybody knows you have to be careful around razors. I did not cut myself. The foam board cuts pretty easily. I'll just show you. Here I have a razor here. And so when you're cutting the foam board, if you just use a slight sawing motion, here, I guess I should hold it up so it's in front of the camera there. It moves pretty smoothly through the foam board. You just kind of drawing it that way. And so, but use a sawing motion so that it doesn't bind, and so there shouldn't be any problems. I mean, the real problems with blades like that is if they jerk suddenly and they cut you. But as long as they're moving smoothly, they're okay. The first thing you build in any of these Mighty Mini series models is the power pod. And the power pod build is the same for all the models, and it's in a different video. There's like one main video, how you build the plane, and then at the beginning of that they point you off to the power pod video for how you make that. So just to show you, the power pod is inside the fuselage here, and it's held in place by these 2 barbecue skewers. So it's like a small box that's made out of foam board, and it has a wooden piece at the front where the motor is attached. And so you build all that first. You make that little box, and you glue on the front piece, the firewall they call it, and then you attach the motor to the firewall. So there's a couple things I wanted to note about this. The first is that these motors come with 3 different sets of screws that have 3 different lengths. So that's you could screw it into plates of various thickness, I guess. So you want to use the very shortest screws because it's a very thin plate. The firewall here is a thin piece of wood with cutouts for the screws. And the second thing is there's 4 screws in each set. So you might think that you want to put all 4 screws on the motor as you attach it to the firewall. And there's 4 holes in the firewall, but the top and bottom holes are actually in the wrong location. And so you just use 2 screws and use it to the right and to the left. Those screw holes are correctly set, and the ones on the top and bottom are not in the right location, so you can't really use them. Actually, the first build I did with the Mini Scout, I just thought they were a little off on their tolerances, and I drilled some extra holes in there so I could get the screws through. So that one was held in with 4 screws. But in looking at the build video carefully, he only actually uses 2 screws. And also when I got the second model and it had the same configuration where the 2 screws on the side were correct and the top and bottom screws were not in the right locations, I realized it was designed that way and you're only supposed to use 2 screws. So that's one point. The second point about the firewall is that as he's building the firewall, he coats it with packing tape to give it some extra strength, and then he cuts through the packing tape with a razor to allow the screw holes. So it just seals the firewall onto the power pod, the box itself. It seals the control wall onto that box very securely. But there's a problem with using 2 layers of packing tape, which is that you're later going to poke these holes through that packing tape and the foam board in order to fasten the power pod inside the fuselage. And even though the skewers have a sharp point, I was not strong enough to break that, and I had to pull it out and cut a hole in there where I thought was the right spot. So it was kind of messy the first time I did it. So what I did the second time was I just used 1 layer of packing tape. The strength did not seem to be a problem. I think 1 layer of packing tape is fine, and I didn't even coat the whole power pod with packing tape. So actually I only had to puncture the packing tape at the front location. And then I just got a little finishing nail and I used that to puncture the hole in. After I had it correctly located here, I just punctured a hole on each side. The holes in the fuselage are already there from the foam board kit. So once you place the fuselage, you know right where to put the holes. And then you can run the skewer through after you've poked a hole in the packing tape. So that's my suggestion for building the power pod. After you build the power pod and before you start building the plane, you can actually hook up all the electronics, and that's something that I did. It's not required, and it's not actually part of the procedure they go through, but I found it reassuring to connect all the pieces and make sure that they were working as I expected. And it kind of helped me understand the wiring diagram of the components inside the plane. So let's take a look at what we've got in the plane here. So up at the top we've got the motor, and behind that is the ESC. The ESC stands for Electronic Speed Controller. So that has the throttle control, and behind that you've got the battery. So the battery actually powers the ESC, and then the ESC powers the motor. So all that makes sense. But also the ESC is plugged into the receiver, and the receiver, you can see, is on this side. It's glued into the side of the wall there. It looks like a little box. So the power goes from the battery, you can't see that, it's shoved up against the motor in there, to the ESC, and then from the ESC it goes both to the motor and also back down to the receiver. And then from the receiver the power goes out to the servos. And the receiver also sends control signals back up to the ESC to control the throttle. And of course the receiver is getting its control signals from the transmitter. But I was just talking about hooking together all of these components here. And so you can wire them all up in that order. Plug in the battery last. So the way you want to do this is plug in the ESC to the motor. And one interesting thing about the motor to the ESC connection is there's 3 wires that are identical. And so you just plug them in at random. And then later on, when you've got it powered on, you see which way the motor is spinning. And then you turn it all off, and then you switch any 2 of those 3 wires, and then the motor will spin in the opposite direction. So if it was spinning in the right direction to start with, you don't have to change anything. But if it was spinning in the wrong direction, you swap any 2 wires in their connectors, and then that will reverse the direction of the motor, and it'll start spinning in the right direction. I want to talk about the wires themselves a little bit. So what the wires look like in there, you could see them, but maybe not so well. So this is an example of the kind of connector you have inside there. And on this side, I can do it this way. On this side, there's a dark wire. The dark wire is ground, and then the power and control are flowing in the other 2 wires. And this type of connector, unfortunately, can go in either direction. You can flip it over and it'll connect just fine, which is a problem. You want to make sure every time you put in one of these connections that the ground wire goes to the ground wire on the other side. So that's the thing to be most careful about when you're doing your wiring. Let's see. The connectors when you insert them into the receiver, it's actually a very tight connection. And so first of all, make sure you locate where ground is on the receiver. And the little AR410 that I had, if you set it up like that with the antenna on top, the ground was the bottom. The plugs went in this way and the ground was at the bottom. But the AR410 actually is not, it's been superseded by the AR410, and that has a slightly different shape. So I can't say for sure where ground is on the AR410, but be sure and locate it before you plug those connectors into it. And it was a real tough connection to get those in. I think it was designed to be that way so that they don't fall out easily during flight if there's some vibration. So it's a very tough friction fit when you put those connectors into the receiver. Let's see. So and into the receiver, you don't plug the servos directly. You plug in wire harnesses, and then the wire harnesses run to the servos, and then you plug the servos into that. So there's going to be 2 connections there you have to make and watch so you get the ground right on each of those. And the wire harnesses come in 2 varieties. They're the ones that are a simple straight connection that are used to attach the servos for the used to attach the servos for the elevator and the rudder. That's these two servos inside this box here. There's an elevator servo and a rudder servo. They just need a single wire harness. But there's two servos on the back. These are for the ailerons. They cause the ailerons to go up and down. And so there is one connector on the receiver labeled aileron, and there's one wire harness which has a Y shape. So it's got one plug that goes into the receiver and then two plugs, one of which, or two other ends, one of which goes to each of the servos, one for this servo and one for that servo. So those servos go on the Y harness. Yeah, the servos come with a choice of attachments. If you look at these servos, let's see if I can get a good view of it. Yeah, that's kind of a good view. You can see the servo is lying flat there, and then there's an arm sticking out perpendicular to it. So that's a single arm. You get the servos in a little package, a little box that's got a whole bunch of different types of servo arms. There's servo arms that have 4 arms. There are servo arms that have 2 arms, and there are servo arms that have 1 arm. So you want the one-armed variety. I think you could actually convert one of the 2-armed servos to a 1-armed servo if you break it by snipping off one end. But you can see the way the servo is installed here, that the servo arm is coming out in this direction. There's no room for this servo arm in the other direction. It would run into the wing there. So that's why you want the one-armed servos. And you want them at right angles to the you want the arms at right angles to the servo. And you can place that at any angle. There's a connector there. You just put it on top and then you screw it in. It's a ratcheted connector. Okay. And the battery. Let's talk about the battery. So the power connectors they're using in their kits are XT60 connectors, and they look like this. They're yellow connectors that have one end is slightly flattened and one end is round, and so that makes it so they only plug in one direction. But a lot of batteries only come with JST connectors, and JST connectors look like this. So they're just have the 2 wires, and so you can buy batteries that have an XT60 connector directly, and that's what I recommend. I actually bought these batteries before I understood all this thing about connectors, so I got the kind that had the JST connectors, and then I had to buy this extra cable here that converts a JST to an XT60, but you don't really need that if you buy the right kind of battery in the first place. But there are occasionally shortages of batteries, so when you're looking for batteries, you might have trouble finding one with the right connector. So that's just a hint that you can actually use a cable to convert the connector from one type to the other. They're completely compatible. It's just the physical connection is different. And so at this point you can connect up all of the electronics, and then you can bind the receiver to the transmitter. That's a process you have to go through so that receiver will respond to signals from the controller that you want, from your controller, not from some other controller. And that's different for each transmitter and receiver pair that you have. Each different kind of transmitter has a different process for doing the bind. So I won't describe that, but just you can go through that at this point. And there's an advantage to doing that. So in the Flite Test Crafty kit, they actually have a device called a servo centering thing. something to do with servo centering. You want to center your servos so that the neutral position on the servo corresponds to a neutral position on your control surfaces, right? So you want this flap to be completely level at the same time that the servo, well, in that case it would be this servo, when this servo is in a neutral position, so that it can have equal play in either direction. So you don't really know, and as you're playing with the servo, you may twist it a little bit, so it might have been right at neutral to start with, but it may have changed. You always, when powering on, you always start by powering on the transmitter first. That's so when you power on the receiver, you've got a signal there. And then I'm going to cut the throttle. So there's an arm and disarm switch on this transmitter, and I put it on disarm. So that means I'm not going to send any signal to the throttle, so the propeller won't start spinning, which is a good idea when you're doing some of these tests. So now I can go into the plane, and I can take the battery. So here's the XT60 connector from the battery, and plug it in to the XT60. There's the XT60 connector going to the ESC. So you just connect those, and like I said, one end is squared off, so you get a so it's easy to determine which direction it goes in. And there you heard the wake-up signal, and you can see the transmitter there has got a little light on it, so that's turned on now. Put those wires back in here. And it immediately puts all the servos in the neutral position. So if they had been far from neutral, you would have also, in addition to hearing the sound of the receiver beeping, you also would have heard the sound of the servos moving to return it to neutral. And you can see I did a pretty good job on this one. All the surfaces are pretty level. The rudder is level, the elevator is level, and there is this one of these. Maybe it's this one. These ailerons are maybe slightly off, but it's real tiny, and you can't really do much better than that. So as I which one is that? That's the elevator. So you can see as I push this up and down, you can see the elevator go up and down. So go right and left. You can see the rudder turning right and left. And where's the? Yeah, and there's the ailerons going. So, and then when you return everything to the neutral setting, everything should be, all your surfaces, your control surfaces should be level. So the thing is, you can do that at any point. If you got your electronics up and working, you can use this as your servo centering tool. Just power on the ESC, connect it to the battery, and then the power will flow to the servos through the receiver. And they'll automatically go to the center position, and you can toggle, or you can manipulate them with the transmitter here to make sure they're really centered. So this is how you center the servos without the help of the little tool that you get in the Crafty kit. And you do need to have the servos centered as you're lining up the control surfaces and installing them. So that's why that's an important step. In building the body of the plane, there's just a couple of things I wanted to point out. So the body of the plane, I mean the wings, the fuselage, and the tailpiece, and putting them all together. So the first thing has to do with the wings. So the wings start out as, well, they're actually two pieces of foam board that are joined together at the center here, but they're flat, and then it's folded over like this to give this airfoil shape. And there's actually a spar inside there that it's folded over. So it's this fold here that I had a little bit of trouble with. This was my first attempt to cut a bevel in the foam board. And you can see, yeah, you can see there's a little cut starting there. That's okay, that's normal. Let's see if I can flip it over and you can see maybe a little better there what's going on. Not so easy. But there's a cut here. If you imagine this piece it's actually on both sides. Both sides have a 45-degree bevel cut on them. So it's along this length here on both sides, and then you fold it over. So this piece is flat. The other one folds over. When I was cutting those bevels, though, I cut through the paper in a couple of places. Now, if it's just a small cut, it might not be a big deal because you later reinforce that joint with some hot glue. But I put a piece of packing tape all along that joint, and it seemed to work okay. On the outside, I put a piece of packing tape, a strip that ran this way. And then on the inside, as part of the build process, you run bead of hot glue, and then you wipe it off so it forms just a really thin layer. And then you wait for it to cool, and then you bend it over. And so that gives it a really strong joint. But I have to say that using packing tape to cover up those cuts seemed to work out pretty well. This has got now a nice smooth leading edge on both wings. I actually had to do it on both sides. So maybe that's useful. Then you build the fuselage. I think that part is pretty straightforward. And you put the wing through these holes here. And you have to, when you're doing that, you have to push the servo arms out of the way. So at that point, the servo arms will become uncentered, and you'll have to put them back. But then you'll want to go through the process of recentering later before you start attaching them. But after you have the wing in the fuselage, then you lined it up to make sure it's centered, and then you glue in the wing. And I actually skipped this step in the video. I kind of figured out that, well, Josh said, make sure that it's nice and lined up before you glue in the wing. And then he went on to the next step after that, which I think was working on the tail or something. So he never actually glued the wing in, but I think you do. And I looked at it later. In the video, you could see that there was like a bead of glue along there. So what I did to glue the wing in is I just ran a thin bead of hot glue along both sides, both top and bottom. So and on both sides, right and left. So 4 lines of glue. Each time you run a bead of glue, and then you take a piece of foam board and run that along over the hot glue to squeegee off any excess, and just to leave it with a thin film there, basically. Okay, so you built the fuselage, you've built the wings, you've got them attached. Then you come to the tailpiece, and here's a funny mistake that I made not once but twice. I did it wrong in both models. I did it wrong in the Simple Scout, and I did it wrong when I was building this. This is the elevator, this flat piece here. And this part sticking up is the rudder. And the rudder obviously goes on the top surface of the elevator when you're attaching it. Yet both times when I was building this, I put the rudder and attached it to the bottom surface of the elevator. So my rudder was sitting like this. And it's easy to do because you're working with them in isolation. And the elevator itself, this is completely symmetric. So it looks the same whether it's right side up or upside down. Well, I mean, it has the same holes cut out in it. So the rudder fits just fine either way. So pay attention to what is the top surface. The top surface is smooth. There's no cuts, there's no control horns, and the bottom surface has this bevel cut in it for the so that the control surface can pivot, and it also has over on this side, there's also a control horn there. So where the control horn is and where the cut is, that's the bottom of the elevator, and so you want to flip it over and then put the rudder in the top. And I wondered how I made this mistake not once but twice. So I went and watched the video a second time. And the thing is, you're working on the elevator in an upside down position as you're cutting the surface and putting in things. And then there's a very brief segment in the video where Josh takes this control surface, the elevator that he's been working on, flips it over in isolation, right? Just flips it over and starts attaching the tailpiece, so the rudder. So it's really easy to miss. So pay attention to that and insert your rudder in the right way. I had to tear it apart and redo it in both models. The next step is to install the control mechanisms and the electronics. So let's start with the control horns on the tail. There's 2 control horns on the tail, one for the elevator and one for the rudder. So over here, this is the this little piece of wood here is the control horn for the elevator. You can see it makes it go up and down as it pulls it or pushes it. There's a control rod that goes through a little hole in the in that control horn, and then it goes through this slot and into the fuselage. And then on the other side, similarly, there's a control horn for the rudder. You can see it pushes and pulls the rudder. It's got a control rod or push rod that goes it's going through the hole. There's a Z-bend, and then it is inserted through the hole there, and then it goes through a slot in the side of the fuselage and into the main compartment of the plane. When you're so you attach those first to the control horns, and then you push them through these slots in the side. Actually, I'm sorry, you do it the other way around, don't you? You push them through these slots in the side, and you want to make sure that they come out of this compartment here. If you're not careful, it'll come in and it'll just keep running along inside the fuselage, and they're quite long, and then they're impossible to work with. So you got to make sure they come out of this first compartment here where you're going to be putting the servos. You want the ends of the control rods coming out here. Going back to these control horns here, one thing I wanted to mention was that they are installed in these little cuts in the foam board, and that's part of the kit. Those cuts are in there to tell you where to put the foam board, and there's a little bit of to tell you where to put the control horns, and there's a little bit of play. It can go up and down, but then once it's glued in, it'll stick at a particular location. But you may have to recut those holes because as you are gluing various other parts nearby, sometimes the glue spills over and seals off those little cuts. So it's okay to recut those holes and insert the control horns in there and glue them in. So you've got the control rods attached to the control horns. You need to attach them to the servos. So the first point is that those arms on the servos, hopefully you can see two control arms sticking out from the sides of the plane towards the center from the sides. Those are, there's actually 3 holes in those servo arms, and you want to put the control rod through the hole that is closest to the servo. So you want the minimum amount of throw. It actually, a small movement of these control surfaces actually has quite a big effect. So you want to really minimize that. So you don't want to overshoot on your control throws. Otherwise, the plane will be really hard to control. Yeah. So for this stage, before you attach them, after everything has been glued in, you actually you need to make sure that you've centered those servos. So go through the process I described before: powering on the receiver, powering on the transmitter, powering on the receiver, and wiggling everything and make sure your servos are in the center position. And then when you attach them and you glue down the servos, you can move them back and forth, slide them back and forth in this compartment as you glue them against the side, and adjust them so that those control surfaces are perfectly level when the servos are centered. And that's another part I had to redo at least once for all of these connections. So definitely be careful with that one. So I spent a lot of time bending these control rods to put in these Z-bends. And you need a tool like this. It's a very handy tool to have. It's a long-nosed pair of pliers, but with a wire cutter here. So because you're going to be wanting to cut those control rods to the correct length after you're done bending them. So you spend a lot of time working with these control rods and bending the wires, and it can get kind of hard on your thumb after a while. So what I found was if you use the handle of a spoon or a fork, I think either one would work, as kind of a shield for your thumb. You're holding the wire with this with your pliers, and then you can use that to bend it without hurting your thumb too badly. Just pushing on it with the flat, slightly rounded edge of the handle on your spoon, your tablespoon or fork. So that's a little tip for bending those control rods. You may want to spend some time practicing those control rod bends before you make the final ones that are attached to the servos, because you do want to get those right. And as I said, I had to redo that. And once the servos are glued down in place, it becomes more difficult. You can still work on it a little bit because you can actually unscrew the servo arm from the servo and screw it back in a different position. There's a ratchet there, so it'll go to a couple of discrete positions which are separated by, I don't know, 5 or 10 degrees, something like that. So it doesn't give you very fine control. It's not like you have a smooth control of putting it in exactly the right position. So the way you really have to adjust it is by tinkering with the bends to get them exactly right. If you don't get it right the first time, the first time through, you just do all the bends at right angles, and if you correctly place the servo, then everything, and if your servo is correctly centered, then everything should just be level, and you should be good to go. But for some reason, when I did it, I was always a little bit off, and I had to redo those. So I discovered this trick of pulling the servo arm off, working on the control rods to adjust the bend, the length of the control rod really, and then putting the servo arm back in. Let's see, any other tricks here? Yeah, so the control, or the power pod is actually loose in here. It's not glued into anything. It's just sitting there inside the fuselage. It's kind of stuffed in, and it's held in place by friction, but it's also held in place by these two skewers here that go right through the sides of the fuselage as well as the sides of the power pod. So I mentioned this before, but I just used a simple 1 3/4 inch finishing nail to puncture those holes in the place where I had packing tape, which was up front here, so that it was easy to get the skewers through. Then when you assemble inside the power pod here, and at one end, at one end we have the firewall and the motor. Inside it we have the ESC, the electronic speed controller, and I put that in so that it was underneath these two rods that go across, the two barbecue skewer segments there that are holding the power pod in place. And then the wires that connect the ESC to the motor are folded in above the ESC. And I did that on purpose so that they're accessible. And so here's a little trick for you. I was flying the first plane, and like I said, I crashed it a bunch of times. And one time I hit it so hard that the motor started reversing and spinning in the opposite direction of what it was supposed to spin. And I actually I haven't read about this before. It just happened. It may be a defect in my motor, or maybe it's something that happens. But I was able to fix it just by the same way you get it correct the very first time you hook up the motor. You just take any two of those connectors, any two of those connections, and reverse them. You just swap them, and then it'll start spinning in the opposite direction again. So I wanted to put this in where these wires could, in a pinch, be pulled out and reconnected. So that's why the wires are folded above the ESC, and so there's this hatch here. This hatch, I didn't add this hatch. This hatch was in the design, so you can pull the wires out through that hatch and reconnect them. You do have to be careful. The connections are very sensitive. They are banana plug connectors, so the connectors themselves are okay, but where the banana plug attaches to the wire is a solder joint that is shrink wrapped, and that will break. I had two of those break on me, and I had to resolder them. So be careful with those connections. So after you're through hooking everything up, you're going to want to check the throws on your control surfaces. So here's an example. Let's see, that toggles it the other way. They give you this little piece of foam board. Well, it's a cutout from the foam board, and it's got an angle cut into it, and you can compare that to the angle you get when you throw the control surface. And you can see that the control surface here, it actually pushes, maybe from this angle it's better, it actually is pushing the foam cutout there away from the edge. So it's got a sharper angle, in other words, than is recommended. Now that was the high rate setting. I could switch this to the low rate setting on my transmitter. Transmitters come with a high rate and low rate toggle, and yeah, it's still it's not quite moving as much, but it still moves quite a bit. This gauge here, so let's show the two settings. So this gauge has two settings here. Let's go over here. So along the bottom, as you see, this is actually a sharper angle. So that's the high rate setting, and there's a shallower angle up here, and that's the low rate setting. And then on your transmitter, there's a toggle over here. And this one, in this case, when the toggle is up, we're at a high rate, and when the toggle is down, we're at a low rate. So what's the significance of this? So a low rate setting is supposed to be a little easier. It gives you more control. Your control surfaces don't move as rapidly and don't move as far. When you're in a high rate setting, or when your control surfaces move too far, the plane moves very, very fast. It's amazing how quickly it can spin out of control based on my experience. So probably as you're learning, you want to start out in the low rate environment. Get used to it there, and maybe you can ramp up to high rate as you get better at controlling it. So it means these models are very sensitive. And I looked at Josh, when Josh was doing the check on the control surfaces. They were also a little bit larger than the recommended rate settings. So I don't know. I think it's somewhat in the design that they're going a little bit further than that angle would indicate. Now you could perhaps change the angle by changing the location of where these control horns are. I guess what's happening is the control horns are a little closer to the line where the control surface is bending. So the closer you are to that line, the more leverage you have, or maybe it's less leverage, but you cause it to bend further. So if you pull it back away from that, maybe it wouldn't bend as much. But well, those are glued in place now, so that's kind of outside of my control. So I'm going to have to live with those control throws as they are. I just have to be aware that it might be pretty sensitive. So anyway, the last topic I wanted to talk about is the hatch. So the hatch, as I mentioned, it's going to be coming on and off a lot because you need to take it off each time you want to change the batteries. So let's go ahead and unplug this battery anyway, since I have it plugged in at the moment. So here's the hatch. Here's the bottom of the hatch, and you can see there's a number of pieces that are in here. These were all originally foam board pieces. This is little foam board inserts. They look like mushrooms. The top side provides a shape to bend this around, the top around, to give that a rounded canopy look. And then they have a square part that just sticks through and attaches to this plate here. And then there was one more piece that went down, and it was oriented perpendicular to these other pieces. And the idea was it had a hole in it, and as you stuck your barbecue skewer through, it would latch this into the plane, because the rod is going through. Yeah, we can show it here. The rod is going through these holes in the fuselage. So when it goes through the holes in the fuselage, it goes through the holes on the sides of the hatch, and then it goes through this hole of this piece in the middle. That latches the hatch down very securely. So I had to change that. This was a piece of foam board, and it's not a piece of foam board anymore. What happened to the original piece of foam board is the first time I tried to stick a barbecue skewer through, when I was trying to get everything to line up, it just tore to pieces because, well, I didn't have it lined up perfectly. But it's also not that, the foam board is not that strong as you start poking holes in it. So what I have here instead is a piece of wood. It's actually just a 1/16 inch sheet of wood that I got from my local hobby shop that I cut to this size. And then I chopped off the foam board where it was sticking out there and cut a hole in it. And then I drilled a hole in this piece of plywood, or wood. It's just a single sheet of wood. That's the size of the barbecue skewer. So, and then I glued it in place. I didn't I didn't hold it till it was completely set. I got it to the right position, approximately, and then I put the hatch on, like this. I put the hatch on the plane, And then I ran a barbecue skewer through there. So that went through the hole. It went on the side of the plane, went through the hole on that piece of wood there, and then it went through the hole on the other side, and the hole in the fuselage on the other side. And I let it dry like that. And so that secured the that piece of wood at the right height. And then the other thing I did, so after that, it was pretty easy to get a barbecue skewer through, but it was hard getting one of these cut-off segments of a barbecue skewer through because they have a blunt edge, and so it just, unless you had it lined up exactly right, it would just hit the side of the, it would just, hit a little bit off and not quite go through the hole. So I took one end of the barbecue skewer and sanded it down and rounded it a little bit. So now, just to show you this once, I'll try to get this on camera this time. You place the hatch here, you get that all down in place. You take, and I marked the end that's rounded, and I just put it through this hole here, just try to get it level by eyesight, and then when it gets to the, when it gets to that solid piece in the end, you can just twist it a little bit, and the rounded end directs it right through the correct location, and it comes out the other side. So now the hatch is really easy to take off and put back on. I don't have to worry that I'm tearing up a piece of foam board inside there. I'm just putting the barbecue skewer through a hole in that thin sheet of wood, and it feels very solidly secured. Even though, as you can see on this side, I damaged the holes on the on this cardboard cover here that makes up the hatch. That's torn there, but it doesn't matter because this is held down by the piece of wood in the center, as well as by the two holes that are in the fuselage. Those are very solid. Okay, so that's everything I had to say about this guy. Hope you enjoyed this video, and I will see you later.